Welcome to Latent Arias, the voice after AI. My name's Nick Rawlings and I'm the creative producer at the studio in Bath. This evening's been co-produced with the School of Art, Film and Media here at Locksbrook. So I just want to briefly tell you a very little bit about what we do at the studio. The studio in Bath is Bath Spa University's award-winning city centre home for enterprise and innovation. We provide subsidised and paid-for space for micro-businesses, artists, innovators, students and graduates to work on projects and ideas that focus on creativity and technology. We offer a range of residencies and a new development programme we've just launched called Build Your Practice, and we focus on supporting our residents to build sustainable, impactful and innovative practices and businesses and encourage collaboration. So I'm really pleased to see some of our residents here. We have just closed our winter intake, but if you are interested in becoming a resident, we will be reopening applications in late spring. So please come and talk to me after the event if you'd like to know more about the studio. We also, as with tonight, run a regular programme of events. So just briefly to let you know about some key upcoming dates. On Friday, April 11th, we are hosting immersive audio researcher and artist Dr. Angela MacArthur. She's going to be talking about her work with the Eco Speaker, which is an omnidirectional 3D audio speaker developed with the Institute for Electronic Music in Graz. Angela's a really brilliant researcher and artist. She's been very much at the forefront of immersive audio research for many years, so that'll be a really brilliant event. On Thursday, May 15th, the studio will be running a major fringe event for Bath Digital Festival's Beings Day. That is at the Keys by Newark Works. We'll be running immersive performances, resident showcases, panel discussions, and a full installation, I hope, of the Immersive Audio Network's mobile ambisonic system, which is a 25-speaker array with sharing of work by artist Nikki Sheff, who recently did a residency with Ian. We always call the Immersive Audio Network Ian. That will be followed by a panel discussion on the future of immersive music with recent Grammy Award-winning immersive producer Hans-Martin Buff, with Real World Studios and Dr. Ruth Farrar, who is the co-director of our Centre for Creative and Cultural Industries. I think I've got that the right way around. Yes, good. And soon after that, on the weekend of 31st May, 1st of June, we've invited renowned sound artist and composer Mark Fell to come and run a weekend-long collaborative spatial sound co-creation weekend. Those tickets, that is a ticketed event, those tickets are now on sale for our website, but we do have a couple of subsidised spaces that will be available by application. So again, if you're interested in coming to that, do come and speak to me afterwards. So you can find more details about our events on our website, and there are flyers on your seats with a QR code that will take you right there. So, to tonight's event. Thank you, Francesco. So a voice really tells the story of a body. It's our sonic presence, deeply tied to our authenticity and identity. A voice is our acoustic footprint, situating ourselves within our own body and its echo, the sonic architectures we move through, and the voices of others. And processing or morphing of the voice has long been a practice that artists working with sound have used to explore their relationship with their bodies, with gender, technology, and speculative futures. So I'm thinking of artists like Laurie Anderson, Arca, The Knife, and the very dearly missed Sophie. They've all employed vocal transformations to evoke a technologized body that's polymorphous, obscured, or transgressive. The technologized voice is also engaged with the voice's political cogency, and from the earliest vocoders used to encrypt wartime communications to the current use of machine learning for forensic linguists' analysis of asylum interviews. But with the emergence of AI, new sonic practices and systems allow artists to expand their voices, singing through datasets that transform and respond to the voice. But with the voice being so intricately and intimately allied to our bodies, what implications do AI voices and AI transformations have? What is the future of vocal performance with AI? How can artists engage with machine learning or AI tools ethically and collaboratively? So those are just a few small questions for tonight. So with that in mind, I'm pleased to introduce my first speaker. Dr. Francesco Bentivegna is a voice studies and immersive performance researcher at the University of Bristol, whose work focuses on embodied and queer approaches to AI, including training their voice to mimic an AI voice, and recently leading the Queering AI project with Watershed. They're interested in the cultural imaginary and mythologies of AI and voice, and recently led the Voice and AI Myth and Storytelling Symposium with the Turing Institute. So with that, I'm going to pass over to Francesco. Thanks very much for coming. Enjoy the night.
Thank you. Oh, that's a heavy microphone. Cool. I don't know how I'm going to top that, because that was a wonderful introduction to voice. But, thank you. Yeah, I don't know if I'm going to use that actually, but yeah, anyway. So, as Nick said, my name is Francesco Bentivegna. I'm a lecturer at the University of Bristol, and my work is mainly on the cultural relevance of voice in the development of the AI myth. So today I'm going to talk a little bit about my background is in performance art and performing arts. So I come from a theatre background, and my relation to voice started as a theatre maker. So I'm going to talk a little bit about my practice, and mainly I'm going to talk about some experiments that I did while I was doing my PhD as practice, as research, in developing a possible relation speculative relation with artificial intelligence as a concept. So the main difference between me and the speakers that are coming after is that they actually do things. I just imagine speculative things. I have no technical awareness of anything. So I'm just here, but also I'm not here. So what I'm going to talk about is this title that I come up with, which is Making Kin Not with the Machine. Making Kin with the Machine, as some of you might be aware of Donna Haraway's work, but is the background on posthumanism and the relation that we interact and the relation we have with things that are non-human, so from animals to plants to ecosystems to technologies and objects. And making kin with is a paradigm that Donna Haraway developed in late 2010s to develop a possible positive vision of the future in the way that we relate to things. So my attempts to understand what AI meant and understand what AI means to people were all around this connection with AI from a vocal perspective, and trying to understand and trying to make kin via a vocal perspective, or make kin as different voices in the space. So I'm going to talk through a little bit, few things in the pattern before I start. So my work is mainly interested in voice and AI and how they interact on stage. So from a humanities mythical cultural studies perspective, and mainly a philosophical one. So starting from Heidegger, going into posthumanism and the relation that we have with objects. A lot of big words that probably we don't need to hear. So mainly I like to, given the fact that I come from a background in voice studies, I like to think of voice not only as a sign of identity or a sign of connection, but also mainly as an instrument for knowledge and analysis. So the big shift that happened in humanities in relation to voice is that thinking of voice as an instrument to understand what happens. What do we mean by that? I don't know. So going beyond the idea of a voice or the voice as main concept that represents identity and centrality of humanity, but mostly focusing on what voice is and what voice does. So what does a voice do rather than what a voice is only. And these brought a series of theories to develop an idea of voicing as in-between. So voice as a link between a voicer and a listener, but voice as an ethereal space that brings in a bag. And this bag is a cultural bag. This is a bag of understanding, a bag of knowledge. That was cool. I didn't know I put that effect in there. But anyway. So to begin this full analysis, let's talk shortly about a simple yet effective dichotomy introduced by Liz Guzman that multiple scholars have used to talk about voices, and mainly artificial voices, because today our focus is essentially on AI and voice, but the field of AI and voice developed from the relation that scholars and technicians and artists had with the concept of an artificial voice. So what Liz Guzman defined is the difference between a voice in the machine and a voice of the machine. So the voice of the machine is when somebody perceives a synthetic voice as the voice of the device that emits it. Okay? So if we look at Siri or Alexa or whatever, any AI assistant or a GPS or a train station, you perceive that voice as the voice of the train station. The other way that we can perceive these voices within the machine is in the machine. So somebody else has recorded that voice, or somebody else has put that voice inside the machine, and the machine is just reproducing the voice. So this is the major dichotomy that Liv Guzman come up with, which is, I think, is quite essentialist, but makes a little bit of sense, because this is the way we perceive artificial voices, and the way we perceive artificial voices performing humanity. So rather than just understanding an artificial voice as something, again, the thinking of a voice doing something, in this case, we perceive voice performing something that we can understand as human, being language, being identity, being connection. We won't necessarily know what to expect from a box talking to us, but the familiarity of the human voice is indeed comforting. So how do we determine this voice? It's essentially through language, obviously, timbre, intonation, and therefore two unconscious biases, gender binarism, in my understanding, and agency. And today I want to talk a little bit about the latter. So what do we mean by agency in this case? So sound studies scholar, oh my god, I forgot his name. Cox. Gone the name. Anyway, explained that adding speech to a technological device suggests agency. I understand agency in this case as the possibility to act or to change the listener perception of the device. It becomes sentient, an agent, a human. In a simple dichotomy, when a listener relates with a synthetic voice as a voice of the machine, they're taking a scientific approach. The device has a voice, And it has agency because humans created it to mimic a human voice. Meanwhile, approaching a synthetic voice as a voice in the machine implies the existence of an identity behind or beyond the device. The device is a hollow box where someone else's voice is reproduced. Both approaches further and evoke imagination in the listener, something more than a simple object or device, but almost sentient, capable of hearing and processing my words as much as I can theirs. We give agency to this box as speaking to us, so this idea of an identity, because they speak, and they are therefore, again, big quotation marks, humans. Siri speaks with us. She is human only because she speaks human language, and this happens due to the anthropocentric urge to assign agency to everything that is human-like. I think that it is important for us to, in this space, to understand this and understand the power that voice can have in terms of furthering an identity and furthering an agency of that identity. As Young argues, in the synthesized voice we find the epitomization of a simulacra, the copy without an original. The idea of voice. The voice becomes a sign of humanity, and the technological object, a human kin, or maybe in the way that I prefer to call it, a person. And what I mean by person is, if you look at the root of the word person, so persona, it comes from the ancient Greek that relates to the theatrical aspect of a mask, and the mask being able to filter the sound. This filtering per through sona, sound, gives agency and gives an identity to the specific person. The person becomes one because of the sound. However, if we stop talking about the voice of the machine or the voice of AI, or the voice in the AI, we could rethink AI in the first place as a series of processes to work with. And I think this is beautiful, and I just realized that this makes a lot of sense looking at the two people talking after me. Because instead of, I think that the main issue for us as artists, assuming that you're artists, but we're all artists, sorry. But us as humans, in the way we understand AI, and the way we understand voice in relation to AI, is to start thinking outside of the box that is given to us, which is either AI is a massive monster that are going to destroy everyone, or AI actually exists and is a human and needs to be taken care of. No. AI is a series of processes that we can work with. Obviously, these processes have massive issues, massive problematics, but what I have been interested in, and that's where I'm going with myself with this talk now, is this, rather than acting as a mythical overpowered being or a perfect ideal of humans, AI is a set of mathematical rules applied to data collection, which are then humanized by us by a voice, or by language. But then again, is voice always language? Or is our language an identity only because it has a voice? If ChatGPT speaks to me, if I see what ChatGPT writes, I don't perceive ChatGPT as a human, but what if ChatGPT speaks to me with a voice? Do I see ChatGPT as a human? I don't know. I don't, possibly. I don't think I do. But what I'm saying is, it is important to detach the idea of the voice from as a singular defining aspect of an identity and include the voice into the conversation of working with, going beyond what it is, but inserting ourselves in a conversation with. So, AI are sold to the public through an imaginative idea of progress, but such progress is shaped and built around approximative training, data, and exploitation most of the time. And it furthers problematic ideals of what humans should sound like, or issues of copyright, reproducibility, and even fraud. There are, however, bright futures ahead and sparkling presents as we speak, and we will see them later with our beautiful speakers after me. So, for us to think through what we're going to see, I propose a third iteration of voice of the machine, of voice in the machine, and this iteration is the voice with the machine. So, to fight the sonorous binary of good and bad and man and woman and whatever, any binary you want to find, but going beyond that and encapsulating a conversation that actually reaffirms the role of AI as a tool, and a tool that needs to be problematized, and a tool that needs to be understood as a tool, not as an identity, or not as a massive, gigantic, enormous monster. There's a beautiful book that I strongly suggest to those of you that would like to work on AI and voice, which is Liz Faber, The Computer Voice, where she goes through all the biases inherently present in the way we understand AI. Liz Faber, The Computer Voice. So that is when, after all this disquisition with my brain, that is where I landed on AI voices and their role in shaping of the mythical identity of AI. How much of a voice brings and furthers an identity, how much the AI becomes a human when it's anthropomorphized, that word? Anthropomorphized? How do you say that? Anthropomorphized, I don't know. I'm sorry. Anyway, English is not my first language, so it's not. And how becomes such through voice? How much of such an identity is co-created, but also what are possible practices of co-creation that do not imply that AI is an identity? Although reaffirming the non-neutrality for non-white and non-hegemonic identities, technology scholar Ramon Amaro, which I strongly suggest again to you, or those of you that are interested in artificial intelligence to have a look at, sees the potentiality of machine composition as a space for affirmative practices of co-creation, a great potential in the non-comprehensible machine logic of computation. There's a computational logic that cannot be comprehended by humans, and I see a great potential in that. I don't know if I fully agree with this position from Ramon Amaro, but I agree that there is a possibility to explore computational arts in a way that is co-creating, but in a way that is co-creating not as if we are dealing with an identity, but as if we're dealing with a tool. Such conversation, as we will see later, embraces AI as a collaborator in the process of creation, as in Hollywood practice, as in many other people practices. But my practice, which I'm going to talk a little bit about now, again, starts from this trying to disentangle our relation with technology from thinking of AI as an identity. I know that this might be the way that we understand it after the 2 years of AI craze that happened in the past 10 minutes? Okay. I can speak faster if you want to. I really like speaking, so that's why I'm... So anyway, so in my exploration of voicing with machines, I embarked in a little practice as research project where I would try and understand what was my personal relation to synthetic voices and artificial voices in the first place, and then exploring it with audience members. So what I did is, this brought me to understanding the role of the voice in the myth of AI, starting from the concept of the grain of the voice, so the very singular, inexplicable trait of a human voice as defined by Roland Barthes, applying it to AI by looking at Pelligrita human vibe, so AI as a machine that tries to replicate a human vibe, and then applying it to the concept of training a voice in contemporary theatre, as developed by Konstantinos Tomaidis, which is training, you're not training towards a specific voice, but you're training towards a grain of a genre. So you're looking a grain of a technique. What it means to learn a technique, it means to learn the grain of that technique. So starting from this facet, I started to go on a little exploration with my little project called Francesco that now is over because I don't have time, but it's okay. So yeah, if you happen to be academics, you understand. This is me kissing a robot. So yeah. Anyway. So my first project was Who's Voicing, where I created an installation that brought the audience member through the history of artificial voices from the very first beginning of the Camplin machine, then Voda and the vocoder, into a specific relation with intimacy and headphones where you talk with a synthetic voice and you see if the synthetic voice can allow you to make you think about the first time you've heard an artificial voice. And that ended with a conversation with Alexa. So this was in 2018, and the conversations with Alexa were quite frustrating and horrible, which still are, in my opinion. But it was quite interesting. It was for me to relate with voices in a way that involves my own understanding of what artificial voice is. Then from that, I moved on to Becoming Robots Through Voice, which is a project that I essentially programmed a computer to teach me how to sound like a robot. So essentially, I was using cheap speech on Ableton. It was very basic. And then I was analyzing the way the cheap speech would sound using the IBM 704 artificial voice and testing it on Praat, which is this software that allows you to see essentially the wavelength, and looking at the wavelength and looking both computationally and perceptually on how to sound like a robot. It was a massive failure, massive. It didn't sound like a robot at all. It's just because I'm not good, but it was just a fun idea. Like again, to see and flip the process of, okay, I'm giving data, but I also want to receive data from the computer. Is this computer capable to give me data? Am I capable to replicate this kind of data? And then my latest project, which is Are You Done? We won't have time to see it. I'm sorry, because I tend to speak much, but it started from my relation with mental health and apps and AI voices during lockdown, which I was always alone, and the only way for me to go about my day was to have somebody that would tell me what to do, and in that case were artificial voices like Alexa telling me, oh, well, good morning, or using apps on my phone. And then I started to flip the process again, and I turned this into a performance where I was on my own in a room, and a lot of people were in another room. They could see me on a screen, and they could put in instructions into a computer, and then the computer will read those instructions to me. And the aim was for allowing the group of people. Oh, have I done something wrong? Am I moving my hands too much? That's cultural. I'm Italian, so yeah, there's nothing you can do about it. Do you want me to do this? I can do this. Essentially, this was a very good experience because you saw the people that at the beginning they were making me do very silly stuff, but then they all started collaborating together and just coming up with things like, do you need to go to the toilet? Go to the toilet. Or can you come out? And they were all trying to make me come out of the room. So sort of then in the Q&A after, there was this conversation of, so how do you feel about in that conversation? How do you feel about in the collaboration with the people around you? So using artificial voices in a way that connect people rather than turning them into a one-off relation, turning them into a multiple people one relation. And it's a sort of representation of also collecting data and then giving them out to an AI to process them. Out of this, what it came out my PhD and my work on AI and myth, and all these three projects allowed me to understand the cultural specificity of the myth of AI and the role of voice in it. And from that on, I've been working on two other projects with the University of Bristol, and one is Queering AI, which is a year-long series of workshops with people that, like me, are part of the LGBTQ community, and we sort of dismantled what we mean by AI in the first place and what it means to work with artificial intelligence, and what is the role and what can we do speculative to queer an artificial intelligence. And then the other project that I'm currently working on is called Page Against the Machine, where we try to, me as a scholar and an artist or poet, try to compose poetry that hints or collaborates with artificial intelligence. But the main work that I've been doing across these two projects is to try to flip and look at the contradictions again, especially in this case of large language models. So normally we act as prompts for large language models. In this project, we flipped. We use large language models as prompts for us to explore, because that's, I think, where the future probably, and no, I'm not talking about researchers in AI, but I'm talking about us, like artists that would like to explore the world of AI. I think that that's the future, treating AI as a prompt-making machine rather than us being a prompt-making machine for it. Thank you so much. I'm sorry I rambled, but I'm really excited for the next one.
Thanks, Francesco. So I'm really excited to welcome Axel, Chemla, Romeu-Santos. I got it right? Cool. Axel is a researcher and engineer working with IRCAM's ACIDS team. ACIDS is a project exploring machine learning for sonic performance and sonic sound design. The ACID systems were most recently used in Holly Herndon and Matt Dryhurst's exhibition The Call at Serpentine, and also for a work by Bjork at Pompidou. But probably more excitingly for everyone here, they are one of the first trainable Sonic AI VSTs that ACIDS has released, called Rave. So we need to give you an HDMI. So Axel's going to talk a little bit about ACID's work and then demonstrate their system. And after Jonathan has finished their performance, the system will be open for you to come and interact with. So, yeah, thanks very much, and welcome, Axel.
Okay, first I remember how to launch this thing. So, hello. So, thank you, Francesco, for all these very, very inspirational insights. I'm totally the opposite. I have the geek casket here, so sorry, it will be technical, and hopefully maybe it will give you some will to play with these tools, and we'll try to be not mathematical at all and provide you like insights and the will to play with these kind of things. We are definitely not really that much focused on voice, but this is really interesting because for us voice is a musical signal. So, don't know what it would imply in semantics, but it's not the subject here. And yeah, so first, who are we? This is the missing slide. That totally were left to the end of the preparation of this conference. And we are where it's ACID, it's for Artificial Creative Intelligence and Data Science. So we are actually like a little group within IRCAM that was actually created by Philippe Esselin and myself and some other people. So it's only PhD, so it's running out, it's refreshing all the day, and so now we are kind of 4, 5 people living there. And I'm personally also like developing that, sustaining that, and also making a lot of new tools that you won't see today. Sorry, because it's not the point. So first, yes. So what we talk about AI-based voice synthesis is just because, very technically speaking, there are like, you know, machine learning, like it's computer science, and computer science needs a task to solve. If there is no task to solve, computer science does not exist, because it's really like people are like this in this domain. So there are like several kind of tasks that are usually taken. Of course, the most favorite that was first tackled by artificial intelligence approach to sound generation was, of course, text to speech, for obvious reasons that Francesco, I think, developed. Then it was also all data with fancy speech processing that was, of course, very, very complete at the time, but not sufficient, apparently. So, of course, there are now a lot of fancy tools like Revocalize or RX that do slightly more transparent voice processing at the cost, of course, of much more computational cost. I won't do ethics now, so just leaving that like this. And of course, now new fancy tools for singing voice generation. I mean, if you really like edit your MIDI, you make the melody of your dream, then that will be transformed with the voice of your dream. So we have a slightly different approach with ACEs actually, because we're more focused on research and musical creation, and by creation I implies finding sound that don't exist, so we cannot be a product, unfortunately, because we are then a little poor, but whatever. And so what would be different actually with this kind of approach is that typically this, I didn't put the brain, but you personally avoid to change the world. I think it's a little too ambitious, I think. But yeah, this thing I really like what I call generate content approaches. It's really like, you know, you have this big button generate, like you communicate with ChatGPT or you generate a song through Sono. And actually it's really impersonal, and I really don't, it's really for people that doesn't think they are creators, but all the people that music producers, creators are really not at all interested with that. It's also focused, and this is a big problem for my perspective, it's focused on reproduction or flow efficiency, I mean, to make things that was long much quicker, or indeed to make realistic voices. And this personally bores me, but I totally understand the need for such technologies. And as I said, the product approach, I mean, we have to sell something. And the problem is that if you want to sell something, it has to work, whatever it means. And the problem is that it doesn't mean anything in most of the times, so I'm not interested into that. We are more what I call a real-time oriented algorithm, so that we don't do much things that want to work real-time, so we combine performance approaches, because music is time, and I think time is very important. If we want our algorithms to work, it has to handle it in a co-creative human-computer way. It also helps to foster originality and novelty, and this is also, and you will discover that very, very quickly. I don't want to make any judgments if the sound is good or not. And you will see, I think it's really important to discard this kind of reproductive mimicking approach. It's very important to just forget that we aim to have a realistic sound, even if we found it shitty. It's the way it is. And also, like a non-product approach, it means making everything open source, because anyway, nobody would buy it. So, and this is where, just to where. So this is also what I call an instrumental approach to AI generation, because it's really focused on non-transparency. We don't want transparent algorithm, we want algorithm that sounds something. I mean, it's very logical for producers and music, actually, synthesizers, people that are used to work with synthesizer, but actually now in the AI myth, as you say, it has to be transparent, it has to be like the perfect mirror of human being. We are not really at all interested into that. We want things that are really sonic, how to say, mark. User-focused, so yes, no generate. Unfortunately, you will have to be involved to use such tools. I mean, some people like it, but some people don't. So, but it's like this. Real time, like I said, and also local. That is very important also, because of course, all the big models like Sono, blah blah blah, you know them, I think. they are really heavy, and so you have to rely on things that are external to your computer to use it. It means that it has totally no transparency. You cannot save it back, you cannot use it on your own computer, and actually it's very impersonal, and it has this kind of server-client mode that totally like shapes the way you interact with that. And this is really, to my point of view, not interesting creatively. And so we make very small models that can work on that, and that, and that, and that, and that, and train, unfortunately not on that, but on small things. So maybe, I don't know if you have a little brother or yourself are playing to, I don't know, Counter-Strike, a global offensive, and you have a fancy GPU in your computer, you can do that. This is where we are now. 2019, it was my first system at the time that was called VS Chaos, at the time where hippies, where AI researchers were a little like hippies with Yoshua Bengio and this kind of stuff, and where we didn't have any idea of what we were doing. And then Rave, that is our star, I mean our climax so far, that was made by Antoine Caillon in 2021, just before the lockdown, and that was never published, unfortunately. But fortunately, there are also musicians that got interested into that. So this is what actually our work started to go beyond our little circle. And then after, that is a brand new model that is totally not a generative model, but we'll see that after. And maybe more, maybe we'll see that. So just to resume, to summarize very, very, very quickly, promised, no mathematics here. The idea of a machine learning model is that it's a function parameterized by numbers. It has an input and output. These numbers that are trainable are here written with a theta later, and they are trained to satisfy a loss function. In generative models, like VS Chaos, Rave, but it's the case, of course, with Midjourney, ChatGPT, whatever, blah, 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 everything that is generative, it's trained to as X as an input and X as an output. So we can say actually what is the interest of doing that, because if we just put something to have the same thing at the output, it has totally nonsense. This is because actually I like to think about cybernetics, especially with machine learning, as it's cybernetical matter, and so actually all your dataset will be printed in the cybernetic architectures. And we are working, for example, in this kind of architecture that are called autoencoders, that has an encoder and a decoder, and in the middle, a latent space. Latent space meaning that it's a representation of the sounds that is usually much more little that the phenomenon is supposed to represent. For example, in images like high resolution images, like millions of numbers, and in this latent space it will be 100. So it's heavily compressed, and compressed in a way that we can use it. And this is called autoencoders. And yeah, this compression step is like, we hoped, at least at the beginning, that it was retrieving high-level components. For example, let's say we're speaking on voice, and there will be a dimension that would be like timbre, the other one, the pitch, whatever. Flash news, it's not at all the case, but we were dreaming of that. And now we just struggle to make it that in that case. But for example, obviously what was doable at the time, because of course we're in 2018, it's really, really not that long, but in terms of AI evolution, it's really like it's antique. I call that now vintage neural synthesis. It was really like just putting chunks that was just spectrums actually in the encoder, represent that in 8 dimensions, and then you can use that dimension to reproduce the sound. For Rave, actually, it's also an auto-encoding architecture, so actually it's more that it's in raw waveform, so you directly learn not the spectrum, but the raw waveform, the pressure of the air. Like, for example, 2,000 samples, represented in 100 dimensions, so there is a comprehension step that is kind of high, and then decoded back into the sound. So there is a wonderful video that was made by a very, very gifted person that is explaining, if you're interested, all that you would like to know on how it works. It's on the website of the Forum IRCAM, so don't hesitate if you want to see a little more. It's explained with fancy graphics that are still ugly, actually. I don't know why, but whatever. So now the main question that would interest you, I think, is that if it's trained on reconstruction, why do we do this? It doesn't have any interest, because I mean, we already have the data. Why do we learn to reconstruct it? It's total nonsense. And computer scientists are weird persons, but not that weird. So what is the point of making that? And before actually showing you examples that would that, like we say, the bias, everything is biased now, but whatever. Let's make first a thinking exercise that how could we use that actually in another way? For example, let's imagine that I have a dog barking and I have a dataset of sounds of dog barking. So he makes woof, harf, or bark, and I train it to reconstruct with woof, harf, and bark. Usually, if you are a creepy mind or a musician that actually do that all the time, you try to put other things into this system. So for example, here we have a duck that makes quack, quack, it's in Estonian, if you didn't know that. And then what would it give? And actually, this is what we call the timbre transfer case, where actually the algorithm has been trained on bark sounds. So he always like outputs duck sounds, just no duck, duck sound, duck barks. So what would it give? We hope that actually makes some kind of weird transfer, where it will be some kind of an hybrid thing. Either it transforms the sound, or if it fails, it still has some relationships with these bark sounds. What you can also do, and this is also a very important thing here, is that you can also use its latent space as a direct actually controls. It's really like, think it about like a synthesizer. You can just use a decoder, you just forget about putting a sound as an input. And this will be a continuous stream of barking texture, something like, see, you know? And what is awesome also is that you can really do some kind of an hybrid between both. So, for example, you have a bark sound that could have been perfectly regenerated, but you are here putting your filthy, dirty hands into the thing, and so it will be some kind of like an effect actually, where you can really shape actually this kind of how it reconstructs that. And so here we could imagine like yes, a transform barking, an hybrid between the user input in the latent space that is like a high-level manipulation space, and the basis of the sound that is somehow respected, we hope, sometimes not. And what is also feasible is that we can also actually totally discard the encoder and learn that you take all the sounds of your barking sounds and you just forget about the original phenomenon and you just take actually the latent trajectories in this space and you try another model to reproduce that. And so it's like a self-driving mode where actually it will navigate into this kind of latent space, and this would typically like make a little forest with a lot of puppies barking at you. Sometimes real, sometimes not, sometimes in a weird way, sometimes realistically. We'll see that in a bit, because this was to introduce you on actually how after and then Ollie Herndon's installation is made. So how do you use it? There is the hard way for geeks, as I am, that is Python, that's where you have code. But I know that nobody loves that. So we actually, to work with musicians, we also made NN-Tile, that is something to embed actually these kind of models into MaximSP pure data for patching environments for music and generative music and patching. And also a VST, so actually, yes, even your little sister who is making us a song in Ableton Live could use to make direct generation. And now it's demo time. Yeah, this is AI generated because it had 3 hands. No, it's fake. For some deepfake alert. So I should begin with that, I think. Let's begin. Yes. And let's also check that sound is working.
Got the bus, so it is working.
Ah, yes, perfect.
That's great. But I'm afraid to bring
Okay, so we'll try somehow. So here we have Rave as a plugin. So actually it's really just something that takes the sound, and what we do with this kind of circles here is actually like manipulating this kind of latent space, to be honest. You'll see. First, let's just, for example, if I have this kind of traditional drum, let's now see how it goes when it passes into a model that has been trained on voice. Actually, it's a leading voice opera singer, I guess. And so we can see that it does this kind of hybrid thing that is kind of awkward. This is a very important thing because if your model doesn't learn silence, he doesn't know how to shut up. And so what is really interesting is that actually this is actually the internal representation of the algorithm, and what you can do is interact with that directly. You can also just randomize everything if you don't know what to do. Something that I love to do also is, for example, try other way to interact with that. So, for example, this is without transformation. So, we're typically in the case where we are in this kind of hybrid things where you can have some kind of the vocal features, but that seems more just coming from hell than from an actual person. But this is, for example, how we can do timbre transfer. That what I really love with Rave is that it works enough to be some kind of realistic, but it doesn't work enough. It's not realistic enough to really think it's like actually it's not a voice. So it's really at the middle, it's of the uncanniness of what could make an instrument interesting, from my opinion. Now let's forget about life because it's too easy to use. And let's jump into the hell, the nightmare of modular patching. Good thing it was from my computer. This is the thing that you can play with if you're interested at the end of the conference. So it's also, I try to introduce things one step at a time. So here, it's exactly what happens inside the VST. At this forward is really taking a sound and coding it. So it's really sound to sound. It's really like using the model as an effect. And for example, I have here this bouncy sound that was generated by totally non-AI means. We have also this one, if you prefer. I think it's Skrillex. I doesn't have the rights, so please. And so yeah, there is this kind of sound. And let's see, for example, how it's reconstructed by this model called Wheel that was actually totally non-legally trained on an audiobook called The Wheel of Time with several locutors. It was unfortunately a model we were used for testing 5 years ago. It has leaked, and so we are really in a big embarrassment because if some people find that out, we are screwed. But it works very well. So here we're typically in the case where it's kind of scatting, so we're kind of happy. This is the model we're using in the VST. So here are kind of realistic timbre transfer things where it kind of works. And this is, of course, almost real time. So, of course, you can have like 5 of them, 6 of them, and just manipulate it, just exploring also with a sound or without a sound, what happens here. More interestingly, something that isn't in the VST is this kind of automatic mode that I wanted to introduce you, because this example is always very fun to play with, because it's very empathetic with the machine in a weird way. Because what happens here is that we have these kind of things here That is called a prior. Prior is a complicated technical terms to say actually automatic generation of latent trajectories. So it has been trained to reproduce the original sounds, but not from the sounds to reproduce sounds, but its trajectories within a single model. So this is a very complicated way to say that actually it will generate some kind of gibberish that you can, I mean, I'm not a native English speaker, so maybe for you it's kind of weird.
We didn't realize that in Indian moonfacts. We looked where it farthest north, soaked land, and were still going to this heat up. The higher they were asked, like they expect the gallery.
We're typically also in a case where it works, but it doesn't work enough. So we can really like, okay, it's interesting. It's not just saying the audiobook, because if it was saying the audiobook, it would say, let's listen to the audiobook. But what is even more interesting is that in Rave, the good point is that all these kind of dimensions, this represents actually all the latent dimensions are these kind of things, because it's also a temporal sequence. So you can also, we drop that into max, so we can modify it by hand during a performance or just to experiment with that. So the prior here actually outputs 8 dimensions because the model has been reduced to 8 dimensions, and the dimensions entering the decoder that transforms these latent variables into the sound. And what's interesting is that we can cut all these little wires to see actually the impact that it has on the sound. And so let's actually, I'm very sorry, but let's slaughter this AI.
The room was something with the copperlight and cleaned. Her eyes started to flood like you was lots. When they felt the time to drop, close at west. There ran the bell wings and the spectacles. Swan break was raised to let Lily to stir flashes, powerful or by my friend's home, quite and so with those under the system. So to the sky, I guess another it's into the sky, fast, thanks,
Bye. And what's very interesting with that is that actually it can really, it can act as an effect if you just encode and decode an original sound that belongs or does not belong to the original database. You can use this kind of automatic pilot that is really like, yeah, the equivalent on a plane, automatic pilot. So it tries to go to the destination. If it doesn't, you are screwed. And you can also like have this kind of course it doesn't work. Perfect. No worries. You can also directly manipulate this as it was in synthesizer. And you can do that actually at the same time. So this is what we'll do with this short example, if it's, okay. So here, there is really no input, it's just the latent dimensions are at 0, and here I have a direct. And so, for example, I can just put several dimensions to listen to this kind of automatic mode, so it can have some variability. You can also like do all the guy that does some kind of modular is like adding some kind of sinusoids. So we can have almost what could be called by everyone an instrument, because it has this kind of plasticity and a diversity of usage that you can really go through and kind of explore, and actually I'm still not bored with that. Just for the record, this was where we were hitting it in 2019 by generating just spectrum instead of raw audio, and because I really love that, because it's it really makes like some kind of slowly evolving spectrum morphologies that I really like to, like a fancy vocoder or something. That has been trained on voice. So it's also to show you if you want to play with a little after. So let's back, sorry, to the technical presentation, because now we will, I will introduce why we are all there. I suppose this is why I was invited, at least, is after. So what's after? Not after, like So after is a thing designed by Niels Demerlich and also Philippe Eslan, that is actually the only one that can have PhD students. This is why he's everywhere, and also because he works well. That has been designed last year, that is based on what is called latent diffusion. A lot of different words in machine learning. There is like, I don't know, 100 popping out each year. It's totally unbearable. But what is latent diffusion is that if we take back actually this kind of system of encoding, decoding that is based actually on a compressed space at the middle, what happens, because here, as maybe you could have seen, but it would be very direct if you try out the thing, is that we have like 8 knobs like this, but we really don't have any idea of what they are doing. This is very interesting, I find, but some people get it very frustrating. So as we want to please everyone, we say, okay, how can we get a more controllable latent space for creative generation? And something that would be at the kind of same style, in the middle of working enough to be like controllable, but not working enough to allow some surprise into the system. And this is where diffusion, I think you heard about diffusion models, because it's a new trend, stable diffusion, mid-journey, blah, 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 blah. What is actually a diffusion model? It's just a neural network that is trained to decode noise. So for example, what happens is that if you take the photo of a puppy, it's very easy to noise it, because you just add noise to that. But once you add noise, it's very difficult to take it back. And actually, diffusion models just learns to deblurry an image. And what is interesting is that actually you can condition these deblurring things with, for example, a prompt. And this is called, for example, Midjourney. This is why also it's so long and so non-ecological, because this process is very hard. And this, you cannot do that on your computer, even with like 3 graphic cards. You cannot do that, unfortunately. So the idea here is that actually stable diffusion Midjourney is not making diffusion directly into the data space, because it's way too high. It's 1 million of data, 1 million of pixels are way too, and it's not possible to deliver it without maybe dooming us, all the humanity. What is done is that it's denoising directly into this kind of latent space, because it's much compressed. And for example, this denoiser, you condition it with a prompt. It's called actually text to image. You condition that with, for example, the text. It's called text to speech. This is how it's done. This is how it's done. And stable audio, for example, of course, is one of these models. But of course, as we are way too hipster to make like everybody else, we wanted really to add this kind of real-time flavor to this kind, because this process is totally non-real-time, and especially where we really wanted to have a hand on self-taught musical features that were opened enough to be generated, to be data relative. I mean, it's really fine. It retrieves this kind of features automatically from the data, but still with this kind of, that would have musical sense, whatever it means. And so their idea actually was to disentangle structure and timbre. And I think it's really clever, because actually it's acknowledged the fact that actually nobody could give a real description of what timbre is. There was a lot of musicologists, music theorists that tried to do so. They all miserably failed. So let's take a negative definition of that, and let's say that timbre is everything but what evolves through time. This is the point, and so there is a very machine learning, very cleverly thought machine learning engineering that I won't describe to you, because I really think you're not interested into that. But the idea is that you can disentangle what is temporal and what is not. So you can actually have separated access. I want to change the temporal structure without changing the timbre, and reversely. And this is actually how after it's done, is that it's still it has this denoising effect that actually translates noise into the latent trajectories that have sense regarding the original data, but that can be controlled in a way to either alter the temporal structure or alter the timbre. And this is why after actually is not a generative model, because a good aspect of that is that it can work with Ray, but it can work on anything that is based on this idea of latent space. So it can be a custom autoencoder, or what is called now a neural codec. This is the really technical stories that are not interesting at all. And now is demo time. This was an autoencoder trained on couriers of a totally unknown origin. Honestly, I don't know what Niels did, so don't ask me. But here you can see that, contrary to the previous models, here the sound is evolving, even if I don't touch all the faders, because actually here you can only see the timbre space. The structure is kind of self-generating, so you cannot access that. But here we have this kind of timbre space, such that actually generates long time frames, so we have to wait a lot more for the results. All of your time of sleep, if you want to sleep on that kind of music. It can regenerate an infinite amount of creepy, coerced sounds. And finally, the Holy Patch. So this is exactly the system that were used by, for the installation of Holy Arden. So Niels designed actually this kind of system that is exactly based on the same concept. It's just that the interface is a little different, and in here actually what you can give is an input that can be an audio input that can be also transformed to control the pitch here. And there is also a target sound that it will try to match, because it can also retrieve actually this kind of timbre embedding from a sample target, taking the temporal organization of this one and kind of actually like make an hybrid between both. And c'est parti. So here, of course, silence, because everything is, I didn't play any sounds, so let's find the target before. We listen to the target. Okay, let's take this one. Let's... We can also, like, by making pitch shifting, kind of manipulates the original note. You can, for example, change the input sound that is inside. So here we are. I have to run very short, of course, sorry for that, but just to have some input on what happens next. The idea is that now that we will try to make actually things much more controllable, especially for voice control, so for example being able to really put a lot of additional informations to be able to shape much more what output, whatever is desirable. Or also make like some kind of latent adapters to be able, for example, from the latent space to just constrain into the zone that would give, for example, a note or this kind of sentence or whatever. And the new upcoming things actually that I have to finish for March is something I work on for 3 years now, is actually what is called network bending. Is that, okay, you take a model, you train it for a single purpose, that you know is that you break everything to make new sounds. I don't think I have the time to show it to you because I think we are running short. But just stay tuned if you want, because it will be released in the next IRCAM presentation forum at the end of March. Everything is free, except all your underground patch, of course. So So yeah, everything is accessible, open source. You can download everything. You can train your own stuff. And yeah, that's it. I don't know. Is there some time left, or?
I think we should move on to Jonathan.
Perfect.
Thanks so much, Axel. That was great, and like we said, there will be time to play with the after model at the end of the event. But now I'm pleased to invite Jonathan to join us. I probably need to give you an HDMI cable as well. So Jonathan is, that is loose. Jonathan is a transmedia artist and musician, and they're going to demonstrate their work and talk about their work, datasets, which was funded by the EU's STARTS programme. They're the co-founder of the Intelligence Instruments Initiative and Netherlands Coding Live, with residencies including a Fulbright Fellowship at the Studio for Electro-Instrumental Music in Amsterdam, known as STIME, and the Institute for Electronic Music in Graz. You might need my face to log into that laptop. Yes, you do.
Yes. Hello, hello, hello. So, hello, everybody. Thank you for having me. Nick, thank you for inviting me. It's so wonderful to be coming after these two particular people, because they're two people who I've had interactions with in the last year or so, and gotten to know their work a little bit, and they've already gotten to know mine. We're also working on like very similar stuff in strange intersecting ways. So it's a very good curation. Nick just ran off, but I wanted to say, like, well done on the curation. I think this is a very cool lineup. Yeah, so this is my talk, Voices Without Bodies, Uncanny Ecologies of Voice AI. Please don't be afraid if I use academic language. We'll try not to. But I am doing a PhD besides being a practicing artist, so I sometimes slip into academic language. Again, sorry ahead of time. I have to mention the people who are paying me. So I'm part of the Sussex Digital Humanities Lab that's in Brighton. I'm part of the Intelligent Instruments Lab that's in Reykjavik. And I'm funded by an interdisciplinary Leverhulme doctoral scholarship, which is funny because I'm the only artist in that whole cohort. The rest of the people are neuroscientists and life scientists. So I'm studying ostensibly voice perception, but I'm an artist. Yeah, so this is an image from the performance practice I've been developing for the last, 3 or 4 years. Pretty much since Rave came out during the lockdown. Antoine introduced it at the end of 2021 at the Neural Audio Synthesis Hackathon. And I was one of the first persons to start using it, and I was immediately hooked because I was just super interested in finding ways of understanding my own voice and how to kind of get beyond my own voice. Especially, this was a time where suddenly you could have any voice. And that's kind of like the golden calf of voice AI, is that you can transform your voice and be anybody. And I was really interested in this. I was interested both in kind of challenging the idea of the ideal voice, or the ideal voices, and also the non-ideal voice, and really kind of making things that are ugly and uncanny and stuff that doesn't match my body. I really like that. I really like the mind fuck of my mouth opening and something really not belonging to my body coming out.
And doing this work, I started, coming more and more to the realization that my body is not a singular thing. My body is a distributed thing. I don't want to get like too woo-woo, but like we are kind of all one. We're all part of a much bigger thing than ourselves. And I think it's quite interesting that we still think of voice as being this thing that's like you, where the more I do these performances and the more I do this work with voice AI, the less and less I think of voice as me. And I'd like to try to challenge that. So I've got my vocal heroes. I've got like sound poets, storytellers. Laurie Anderson was mentioned in the introduction. She is an absolute artistic hero to me. But I've always, even when I was like a teenager playing around with like a hacked version of Cubase, I was always really interested in transforming my voice to explore like different genders and different personalities and stuff like that. Kind of like the mask analogy that Francesco gave. I really love that. Thinking about voice masks. And as a performing artist, I also think, well, how do I embody these things? I'm not just transforming my voice, I'm also kind of there performing with this voice that's different from what my hardware is doing. And I can do a lot of things. I can explore ugliness, I can explore idealism, I can explore the genders, I can explore the species, I can become multiple. That's a really fantastic thing. But it is good to note that although this all seems really exciting, and it is exciting, it's not new. Not only is this not technologically new, I mean, this has been possible in labs previously, it's just that the technology is becoming more accessible. But voice itself has always been kind of this in-between weird thing that's been hard to nail down. I mean, it's inflected with all kinds of things that are not you, like your culture or your upbringing, or if you're a singer, the traditions that you're a part of. So you're already kind of like, your voice is not yours completely. And this is especially true in electronic music. So I would even go so far as to say that, in the tradition of electronic music, the connections between bodies and sound has always been weird. You've always had, sounds coming out of boxes that aren't really vibrating. Computers, electronic devices. Where's the body of that thing? Previous to electronic music, you needed a body. Be it a resonating body like a cello or something like that, or a human body. And I think this is kind of one of the things for me that's always been the most interesting thing about electronic music and one of its defining qualities. So, a little bit more about my artistic work. So I come from Florida, which is Hickville. I was part of the folk traditional scene there. I play the banjo, that's my instrument. I came to Europe and everybody made fun of me and I felt really bad. But I think in the UK it's a little bit more chill about banjos. There's enough of a banjo crowd here. But what that meant was I came from a sort of background, a musical background that had very specific values attached to it. In terms of materials, like I was studying electronic music composition at the same time that I was playing folk traditional music from like pre-American Civil War, right? So I got this great idea, well, let me combine the two, let me like make some crazy like Aphex Twin meets Deliverance kind of music. And I brought a laptop on stage to one of these sort of porch jams, and I literally got kicked off the stage. They refused, they saw the laptop, they were like, no. And that is something that's sort of stuck with me for a really long time. Because I was like, why? What is this? What is the problem? And in the end, I really started to think, this is a material culture problem. There is a mythology and a material reality around computing that just does not rub elbows with making your own instruments, passing songs down from like father to son or whatever, the way that the folk ecosystem works. So pretty much all of my work, artistic work, and I'm going to get way away from making electronic banjos, still has that kind of friction at the center of it. So I'm really interested in how material cultures kind of come into friction in music. And in the case of this symposium, voice. So, yeah, Francesco already mentioned progress, and all of my work kind of deals with this notion of progress, and how like digital technologies have sort of become inseparable from the idea of progress, at least in like the popular cultural narrative. It's still going, amazingly, after, you know, disaster after disaster after disaster. Like, there's still this talk about progress, and I'm blown away by it. Martin Luther King Jr. has a great quote where he talks about, we have guided missiles and misguided men, and he was calling for kind of a spiritual awakening. And it's like, you know, when do you integrate something besides like a better algorithm into your notion of progress? I don't know. Hopefully soon it will happen. I think it's coming. But when you think about progress, you should always kind of raise a couple of questions, like progress for whom? Who's getting this progress? You know, it's probably not you. Progressing towards what? Like, what is this progress going towards? You know, I mean, probably not something you want. And according to which values is this progress moving? When somebody's trying to sell you something as being the next big thing, or progress, or whenever you get caught up in a hype cycle around technology, you should always kind of just take a step back and maybe ask some of these questions. So, describing my work, and I will actually show some of my work, I promise. Describing my work, Marco Donnarumma, who's a friend of mine and an amazing performance artist, performs with like AI and robotics and stuff like that, and he's covered in tattoos and he's usually naked. He also is a scholar, and he wrote this about my work. And you know this kind of thing where you don't really know what you're doing until somebody else writes about it. I felt like this was that moment for me, because I don't use technology as a tool. I use it as a conceptual territory. I try to get into it, and I have formal training in mathematics and computer science besides my artistic training. So I can get really deep, and I can find the poetics of the conceptual territory, and I kind of like leverage that as much as I can. So just a couple examples that sort of illustrate this. My first work, probably my first like major like art technology work when I stopped playing banjo in folk bands, what involved, I came across, so this was back when I was at Stein in Amsterdam, this amazing place, you should look up the history if you get a chance, studio for electro-instrumental musics. They were like pioneers of trying to figure out what to do with human bodies when you have machines that can make music. I found all of these old iMacs from 1999 there. They're just sitting on a shelf, and there was like 20 of them. And they didn't run any of the software anymore. They didn't do anything useful. But they were this kind of cultural icon. Like, they didn't want to get rid of them because this was the first Apple product that came out after Steve Jobs rejoined Apple. And this was the beginning of Apple being like cool, right? So there's this kind of like, oh, you know, the thing doesn't do me anything good, but it's beautiful and kind of chic, and I want to kind of hold on to it. So I asked if I could have them and just turn them, like destroy them as a performance. And they let me have them, so that was cool. And so I did a series of performances where I built these kind of sound amplifying probes, a special kind of hardware, and I would run software on the iMacs, like stuff you would know, like the Mail app, or I don't know what Safari. I don't know if Safari is still a thing. Or, yeah, Safari was a thing back then too. So like all of these apps, and you know, these are creating different kinds of signals in the computational hardware. If you have the right kind of probe, you can actually pick up those signals, and you know, time varying signal is sound if you amplify it. So basically, it was like opening up the computers and using them as instruments, like sound, making sound out of them. So did a ton of different performances. One of them at the Stedelijk in Amsterdam, which was like a full day long performance where we disassembled these 3 iMac computers. Yeah, technology is a conceptual territory, working from the inside out. So this is a little bit more to do with the topic of AI and data. So this was a theater production I was commissioned to be the composer for, called Brave New World 2.0. I hated the title, but we went with it because the director was a little bit of a jerk. And he wouldn't listen to my media critical, educated, a hipster self. But the idea of the play was brilliant. So basically, if you've read Brave New World, it's kind of like this weird, like utopia dystopia where people live in ignorance of history, and so they're happy. They take drugs all the time, and they know nothing about history. So there's basically this kind of end of history. It's just like stuff stays stable, stays the same all the time. And this was that world sort of reimagined in a sense where that end of history came about because of a global AI system that just started taking care of everybody. It wasn't taking over, it wasn't like a Terminator. It was just taking care of everybody, right? And everybody was just living their stupid lives, in this perpetual motion machine. And the AI was just recording everything that people were doing, was advising them on everything from who they should date to, what they should have for breakfast. And I was tasked with the idea of like turning this idea into a musical production. So I composed all the music for it. I built, what you see in the background is a kind of tape machine instrument that is performed live by percussionists and myself. And so you can sort of manipulate the tapes, you can like hit them with sticks, you can do all kinds of really cool stuff, and this was all integrated into the music of the performance. And the idea was each performance, all of the dialogue and all of the music from the performance is fed into these tape machines and is actually recorded, and then becomes the material for the next performance. We did like 30 performances of this show. So we're kind of like these archivists that are just kind of collecting, and then spitting it back out. And this was kind of my metaphor of this like AI system at the end of history, just kind of constantly giving you weird recombinations of whatever humans have produced and put out there. And then this idea kind of carried into another work, and this is actually the first time I started working with machine learning proper. This was, yeah, 15 minutes, okay. Let me skip ahead. So I just very quickly talk about this. This was in 2018, and this was shortly after WaveNet and Tacotron and some of these like early TTS models started coming out. And I was really interested in the aesthetics of these models and when they can't learn stuff. Mm-hmm. So I tried to create a voice clone of Samuel Beckett, and Samuel Beckett was notorious for not ever wanting to be recorded. So there's about 10 minutes of Samuel Beckett's voice out there on the internet, which is not enough to train a model. So what you get is like a gibberish machine of sort of Samuel Beckett sounding stuff. So Samuel Beckett was kind of resisting datafication in AI before it even existed. It was kind of cool. And the idea was that he was having this conversation at the end of history in some data set where all that's left is these algorithms sort of feeding on whatever has been recorded and put on the internet. And of course, Beckett was not on the internet, so it was really struggling to create a Beckett clone. I'll skip ahead a little bit. So back to voices as traces of human bodies. How do they get transmitted between generations? What people, yeah, I mean, this is a great quote by Kittler. You should just have this one. But I'm going to skip ahead a little bit more. I'm going to skip ahead. Unfortunately, skipping over a very cool project that I would love to talk about. But I want to get to the meat of datasets, which is the big thing that I've been working on for the last year. And let me get to my news. So this is funded. This was this big starts funded project, which means they give you a bunch of money, they pair you up with a bunch of really interesting collaborators. And the core question of this was, how can data sets, and particularly voice data sets, and the sort of hidden human embodied labor of their creation and the situatedness of their context be foregrounded in an artistic experience? So let's get away from like the hyper-realistic voice clones, and let's get to like the ecosystem behind them. And this project was massive and involved workshops, involved developing a new piece of software, involved making relationships with artists. This is a Slovenian experimental vocalist, Irina Tomazin. She's making a non-voiced voice data set. If you hear very closely, you'll hear some scratches. This is the Toloka ensemble. They're a Ukrainian polyphonic choir. And especially I've been working with the sound poet Jan Blanc, who's kind of become my mentor. And we developed a whole performance of him basically making data sets. Making data sets for voice is very boring and very time intensive. So we made a score system for it, and he would perform these scores, and we would record them live, and then I would duet with him using a clone of his voice that was trained on whatever the latest data we got was. So this is this custom software we built called Tuna, which is meant for exploring sort of paralinguistic sounds. And using Rave as a vocoder, important to mention. And then the final thing to come out of this project was more of a kind of around the ethical and economic and commodification aspect of voices. Like, can we think about vocal values? Like, are there values that we hold specifically to voice? You know, it's an interesting question that we maybe don't ask ourselves very often. And it gets back to this question that Francesco rose about, like, what does voice do? Maybe what does it do well? Materially, culturally, spiritually, physiologically? How does it shape our relationships to others, establish value systems, and then how can these value systems align with AI data practices? So I did a bunch of workshops with Mozilla and other partners, trying to just get an idea of like what people thought was valuable about voice and how that vibes with what's going on in the AI voice ecosystem right now. And it sort of developed into a manifesto. These are some of the points in the manifesto. Called it Vocal Values Manifesto or Statement of Vocal Values Principles. It's at vocalvalues.org if you want to check it out, or if you want to contribute to it, reach out because it's supposed to be a living document. Yeah, that's all I got. Sorry if it's a bit rushed.
Cool. I think, are you ready to also perform briefly?
Yes, I can do it real brief.
I think about 10, 12 minutes. Lush. Thank you so much, Jonathan. There's a little bit of singing for the machine when you're working with no systems, isn't there? Some of the sounds you're making, you wouldn't want coming out the other end of that microphone, right?
Oh, absolutely.
It's 8 o'clock, so thanks for staying with us. I hope you've enjoyed what you've seen so far. Axel is going to have their system ready to interact with, so if you want to come and sing into the holly patch, I think that's possible. And we've got some more documentation of Jonathan's work playing in the Bleachers Theatre as well. Our bar is still open for another half hour, so do get a beer if you want to hang out. And I think we'll go straight to hanging out. I think panel we don't need. We've done a lot of talking tonight, so thank you very much, guys. Come and chat to us. Thanks very much to Jonathan Chaim Reus. Thanks very much to Axel, Chemla's Romeu-Santos, and Francesco Bentivegna. And yeah, I got the soft GN right. Yeah, I can do it. I can do it. Cool. Thanks very much, guys. And come and see us on the 11th of April for Angela MacArthur. Thanks.